So with this video, I'm going to talk about the three main types of reactions, and then we're going to look at some examples and classify them as either precipitation, acid, base, or redox reactions. So you've already read the chapter, so you have a little bit of background about these three. So let me just give you kind of the quick and dirty details of what to look for and what each of them do. So precipitation reactions are going to be reactions where you're going to take two aqueous compounds, two aqueous reactants, mix them together and form a solid. Okay, so these have everything to do with solubility. Okay, so again, you'll take two aqueous reactants, and you're going to form at least one solid product. Okay, one solid product. So two aqueous reactants and one solid product. So when you're given a bunch of chemical equations and you're trying to figure out which of the three it is, you can easily either assign or discredit this precipitation reaction by looking for the states in your reactants and in your product. So in the reactant side, you're looking for all aqueous, and in the product side, you're looking for at least one solid compound being formed. Also, just quick to note about the solubility chart. Solubility rules. Okay, on your LOA cheat sheet that I've given you, and the very back, at the very bottom are solubility rules that you can use for your learning outcome assessments quizzes. So these rules are not something I expect you to have memorized, no way. There's other things I'd rather have you memorize. You can always look up these solubility rules somewhere, but I would suggest these rules, I mean, it's the same rules that are rules in your book, it's just formatted differently. So I would suggest making sure you read over these solubility rules and make sure you understand how to use this chart, right? So they have soluble ionic compounds on the left side and an insoluble ionic compounds on the right side, but there always seems to be exceptions to all the rules. So again, just having this chart handy and using it while you're completing your homeworks is going to help you figure out how to read it for when you take your learning outcome assessment quiz. Okay. So again, that's precipitation. So two aqueous reactants forming one solid product. Okay. Acid base. That uses an acid and a base. So when we're looking at acid compounds, you're looking with compounds that have a hydrogen in them, right? So H2SO4. It's also good to just start memorizing some of these very common acids, especially the strong acids. So HCl, HBr, H2SO4, HNO3. So nitric acid, hydrobromic, hydrochloric, sulfuric acid. Right, so these are common acids you'll find. For bases, you're looking at one of two things. Actually, let me put one more acid on there for you because you end up seeing it a bunch. So the ammonium ion is also an acid. Remember, the definition of acids are their proton donors, H+ donor, right? For bases, you're looking at usually one of two things. You're looking for hydroxide anions, or you're looking for ammonia, NH3. Sometimes it can just be a nitrogen that has two things bound to it. So this R letter denotes any two things that are bound to it. But so a nitrogen that has three things, sorry, that would be three things bound to it. Okay, so these are good examples of bases, and bases are H+ acceptors. Oops. Right. When you have an acid and base reaction, remember, I'm going to erase one of these couple of these obvious strong acids at the top, that you react an acid plus a base and you form a salt plus a neutral water molecule, right? So those are acid-base neutralization reactions. So telltale signs that you are looking at an acid-base reaction is if you're finding hydroxide in one species and a hydrogen in the other reactant species, right? Because the hydrogen's usually indicative of its being an acid, and either a hydroxide or this ammonia or a nitrogen with three things bound to it is a basic compound. So that's one thing you can look for. So you're looking at the reactants, you're analyzing the reactants. You're also analyzing the products and looking for, was a water molecule formed? And also, did you form a salt compound of some sort? Okay. All right, so and then redox reactions are our last one. In redox reactions, you'll see one of two things. You'll see either a transfer of electrons transfer of electrons, or you'll see a change in oxidation number. Okay. If you have not already, you should watch the Hughes views on assigning oxidation numbers. Okay, so that's going to help. So with that. All right, but that's the one of two things that you'll see. So just to recap, precipitation reactions, you're going to see a solid in the product that came from two aqueous species. Okay. You also could check yourself if you have time and look at the solubility rules and see, is that solid product one of the insoluble compounds on your solubility rules? Acid-base reactions, you're looking for an acid, so something that has a proton, something that could donate a proton. Also, having known some of the very common acids will help you tremendously immediately identify, oh, there's the acid, plus a base. So for bases, remember looking for hydroxide or a nitrogen with three things bound to it. Okay. Also, you're analyzing the product side to see, did you form a water molecule and a salt compound? Because if you did, then you're definitely looking at an acid-base reaction. And lastly is the redox reaction. So you see either a transfer of electrons, or you're going to see changes in the oxidation numbers of the species. One quick and dirty redox reaction you'll always see is combustion. Okay. So combustion reactions, that's where you take any compound. I don't even know how to begin, like making up a compound. It could be sorry, I keep pushing this little button on my pen. CXH to the Y, O to the Z. It can even have nitrogens in it and sulfurs in it. So I've just written some, some crazy compound, but what you're going to see is it's going to react with molecular oxygen and give you, based on what you're combusting, what you're burning, these specific products. So if you've got a carbon in your reactant, you're going to form CO2 in the product side. If you have a hydrogen in your reactant, you're going to form a water molecule. If you have oxygen in your reactant, well, it has to be coupled with carbon or hydrogen at least. But you'll see it appear as the oxygens in the CO2 and the H2O and these other species I'm about to show you. So if you have a nitrogen, you'll see what we call NOx compounds, NOx. So the X is usually either a 2 or a 3. They're covalent compounds, so like nitrogen monoxide, nitrogen dioxide, nitrogen trioxide, so on and so forth. And if you have a sulfur compound, you'll find that you produce what's called SOx, S-O-X, so SO to the X. So that could be SO2, SO3. You'll form those kinds of compounds. Okay. So again, if you have oxygen, you'll see that oxygen appear in a couple places. It could be in these compounds. It could be, in that CO2. It could be here. So it just kind of shows up everywhere. Okay. But the better species for combustions, I guess, to follow would be carbon, hydrogen, nitrogen, and sulfur. You will see them over here on the product side as these types of species. Okay, so with all that said, let's look at, it's question 14 of the exercises, so at the very end of your chapter, and this one doesn't provide you with answers, so that's why I was going to do it, so I can provide you with answers here. All right, so it just pretty much said classify these 4 reactions as either precipitation, acid base, or redox. So I would personally eliminate precipitation and acid base, because if we know those two, then you can pretty much assign redox to the other, everything that doesn't fit, right? So the very first one, precipitation, I'm going to look at the states, right? I've got a gas and a solid and a gas and a gas. So nothing precipitated, not precipitation reaction. So that's out. What about, is this an acid-base reaction? So my telltale signs. Do I have proton donor? Hey, well, water has H in it. Water technically could be a proton donor. Is carbon a proton acceptor? No, that's not a base that we've talked about. That's just elemental carbon. Did I form a water molecule in a salt compound? No, I did not. So this does not hit any of the boxes either for acid-base. So if it's not precipitation, it's not acid-base, this one has to be redox. And you can prove it to yourself because you can just look at even the oxidation of the carbon. So elemental elements, remember from our video, elements have a redox value of 0, but an element in a species, you have to think about it. So oxygen is always -2, so the carbon bound to this oxygen to make carbon monoxide would have to be +2. So my carbon went from a redox number of 0 to a redox number of +2. So it is a redox reaction. All right, let's check the next one. I've got a solid, so here we go. I'm going precipitation first. Solid turns into a solid and a gas. Nope, guess what? That's not precipitation because you need 2 aqueous things to make a solid. Is it acid base? It can't be acid base because you only have one thing on this side. So we're not reacting an acid or a base. There's just one reactant here. So this again has to fall under redox. If we look, we could probably determine what's the redox value of this chlorine, and I bet that'll do it for us. So let's do the redox numbers for this chlorine. So remember, oxygen's always -2, but you have 3 of them. So oxygen right here is a total for -6. Potassium is group 1, so it's always +1. So that leaves my chlorine to fill in the gaps. Overall, KClO3 was a neutral compound, right? There was no like -1, -2, or positive. It wasn't an ion. So that means that all these values, so this value plus my chlorine redox number plus my oxygen values has to equal 0. So chlorine in this case has a redox value of +5. Okay. If I look over here at my KCl, right, potassium is always +1 and chlorine is always chlorine in this case is -1 because it just has to balance out so that these redox values added together gives you that neutral net 0. So the chlorine went from +5 to -1. So yes, indeed, again, I just proved that was a redox reaction. I did it quicker though by just canceling out it's not precipitation, it's not acid base. All right, here we go. Next one, C. So I've got aluminum hydroxide with 3 hydrochloric acid. Hold a minute, right? HCl, you should have big alarms going off that this is an acid. I look over here, do I see hydroxide or nitrogen with 3 bonds kind of on it? Yes, I do. Here's hydroxide right here, so I have a base. Let's finish the checks and see, do I make a water molecule? Yes, I do. Do I make a salt? Aluminum chloride is absolutely a salt compound, so this screams acid base, totally screaming it at me. All right, last up, let's check. So I've got lead nitrate, aqueous, plus sulfuric acid, ooh, aqueous, yields lead sulfate solid and nitric acid aqueous, HNO3. So remember, H2SO4, big red flags, acid, acid, ooh, it's an acid. All right, but is PbNO3 a base? Do you see hydroxide or you see nitrogen with 3 things bound to it? Oh man, this is Dr. Hughes, you killed me. Yes, this is a nitrogen with 3 things bound to it, but NO3 is not a base. It is not really actually, I mean, technically it is a base. Okay, here it is a base. And this, okay, so we do have a base, man. All right, so we do have a base, we do have an acid, but is this acid base? Did we form a neutral water molecule? No, we didn't. But what did we form? If you were following the states, we had 2 aqueous compounds and made a solid compound. So even though you are reacting an acid and a base up here, you're not forming water or a salt. Instead, this is a precipitation reaction because you've got 2 aqueous compounds that make at least 1 solid compound. So this one is precipitation, which I usually denote as PPT. All right, so that is 3 types of reactions overview and how to look at these chemical equations and how I kind of want you to be thinking and analyzing them to determine what type of reaction they are.